Welcome to this channel. In this video we are going to solve this problem: x cubed plus x squared equals to 36. And as you can see here, the first move I'm going to take, of which I'm already taking here, is to subtract 36 from both sides. That is minus 36 from both sides of the equation, of which you can see at the left hand side, at the right hand side, 36 cancels out because 36 minus 36 will cancel each other. Then on the left hand side we now have x cubed plus x squared minus 36 equal to 0. Okay, that is the first move. Now we are going to write negative 36 as negative 27 and negative 9, because when you add negative 27 together with negative 9, you are going to get back your negative 36. So with that being said, that is the next step we are going to take. Then we get x cubed plus x squared minus 27 minus 9 equals 0. Now looking at this, the next thing to do is to write 27 in index form and 9 also in index form. This is for the purpose of grouping like powers, those that have the same power, so that we'll be able to group them and do expansion. That is just the purpose of this step here. So as you can see, we are going to group those with power 3s and those with power 2. We have x cubed negative 3 cubed plus x squared negative 3 squared, everything equal to 0. Okay, so now there is this formula. Should I call it a formula or a proved expansion formula, that when you have two, like a raised to the power 3 minus b raised to the power 3, if you expand it, you are going to get a minus b in one bracket into a squared plus ab plus b squared, where a and b in this case is x and 3 respectively. And for the difference of 2 square, of course we all know difference of 2 square is the product of the sum of the two numbers and the difference of the two numbers. That is a minus b all in bracket into a plus b. Hence we are going to write this x cubed minus 3 cubed as, okay, we are going to write that as we are going to write that as x minus 3 into bracket x squared plus 3x plus 3 squared. Okay, then for the difference of 2 square, we have x minus 3x plus 3. Okay, everything equal to 0. Now if you look at them, they have something in common. The first term that we expanded have x minus 3 in common, and the second one, which is the difference of 2 square, also have x minus 3. So you factor it out. You factor x minus 3, you now have x minus 3. What is left for the first term will now be x squared. When you factor out x minus 3 from the first term, you have x squared plus 3x plus 3 squared left in that side. Then for the second one, which is the difference of 2 square, when you factor out x minus 3, you are left with x plus 3. So everything being equal to 0. Now there is a fundamental principle, which I call a principle or a law, that when two numbers multiply each other, or two things multiply each other to give 0, it therefore means that either the first one equals 0 or the second one equals 0. Although let's simplify this last expression. Let's simplify it before we apply that rule. So we are simplifying. We simplify it from x squared plus 3x plus 3 squared plus x plus 2 plus 3 rather. we simplify it to x squared plus 4x plus 12, which is a quadratic equation. Now, given that x minus 3 all in bracket x squared plus 4x plus 12 equals to 0, it therefore means that either x minus 3 is equal to 0 or x squared plus 4x plus 12 equals to 0. Just from that fundamental. For instance, if you have 4 times 0, it will surely give you 0. Or if you have 0 times 10, it will surely give you 0. That means two numbers multiplied to give 0 implies that either one of the number is equal to 0 or the other one is equal to 0. Now, let x minus 3 be our first number A and x squared plus 4x plus 12 be our second number B. Now, when x minus 3 into bracket x squared plus 4x plus 12 equals to 0, it therefore means that either x minus 3 equals to 0, which is what I am writing now. Either x minus 3 equals to 0. Okay, either x minus 3 equals to 0 or x squared plus 4x plus 12 equals to 0. Now you could see that we have gotten two different new equations. X minus 3 equals 0 or x squared plus 4x plus 12 equals 0. Now for the first one, x minus 3 equals 0. If we add 3 to both sides, we are going to get x equal to 3. So that is the first solution to the problem given earlier. So that problem that was given to us, the first solution that we've gotten, which is the only real solution out of the 3 different solutions of this problem, is 3, and we have gotten it here. Now we are going to get the remaining 2 solutions out of this second equation that was formed, which is a quadratic equation. And I'll use this opportunity to teach us how to solve quadratic equation using complete square. As you can see, the first step I took is to make sure all x terms are in the left hand side while constant is in the right hand side. So we have x squared plus 4x equals to negative 12. Now the next thing is to express the left hand side as perfect square so that it will be x plus something to power 2, that is square to power 2, x plus something to just a power of 2. And in this case, we are adding 2 raised to the power 2 to both sides so that we can express that left hand side as x plus 2 all raised to the power 2. Then it will simplify the equation a bit. Now you establish it that make left hand side perfect squares by adding 2 raised to the power 2 to both sides. And how I know that I am to add 2 raised to the power 2 is because you have to pick the coefficient of x. Look at x, which is 4, having coefficient 4. Pick 4, divide it by 2 and square it. So it is for any other equation, whatever is the coefficient, be it 6, so pick the 6, divide it by 2 to give you 3, then you square the 3. So now we have the left hand side now to be equals to what we wanted, a perfect square. In this case, which is x plus 2 raised to the power 2. Because if you expand x plus 2 raised to the power 2 like I'm doing here, you will get back our expression x squared plus 4x plus 2 square, which is the left hand side. So that's what I'm trying to do. Look at it. X plus 2 all raised to the power 2 is the same thing as writing x plus 2 in 2 places multiplying each other, of which if you expand it, you will get this x squared plus 4x plus 2 square, which is our original left hand side. So that's it. You can see now. So now we proceed. Negative 12 plus 4 gives negative 8. Now when you take the square root of both sides, the square in the left hand side cancels immediately, because square root cancels square, square root cancels square. Okay, now we now have x plus 2 equals to, now take note, whenever you take square root of anything, you have 2 values, plus or minus. So immediately we introduce square root, plus or minus was introduced. Now we have plus or minus. Root 8 can be written in its simplest form. Root negative 8 rather can be written in its simplest form. We're going to be looking at, it can be written as root of negative 8 can be negative 1 times 2 times 4. If it multiplies 3 things, you will get back negative 8. So now from the root of sort, the root of 3 different elements multiplying each other is the same thing as the root of the individual elements multiplying each other. So root negative 1 times 2 times 4 now will give you it will give you root negative 1 times root 2 times root 4. So it will give you that. Now We are going to simplify. Root 4 is the same thing as 2, because square root of 4 is 2, right? So now 2 times root 2, we are going to take the multiplication from the right hand side. 2 times root 2 give 2 root 2. Then take note, root negative 1 have no value in the real number system. It only have value in the complex number system. So and its value is I. So you replace everything that is there as root negative 1, replace it as I. Now after replacing it, you now have I times 2 root 2. So that's what I'm trying to point out here from our knowledge of imaginary number. Okay, root negative 1, anywhere you see root negative 1 in computations, anywhere at all, is equal to I. So in place of root negative 1 that is here in our problem here, we'll put I there. Then I times 2 root 2 gives us 2 root 2I. Okay, so now we are now going to write root negative 8 being equals to 2 root 2I. Okay, so our plus or minus was there initially, so we'll put it down there. Plus or minus 2 root 2I. Now, to make x stand alone, which is the x that we are looking for, subtract 2 from both sides, so that 2 plus 2 minus 2 will cancel on the left hand side. Then we'll now have negative 2 plus or minus 2 root 2I on the right hand side. This means that we are going to get two values when we do negative 2 plus 2 root 2I and when we do negative 2 minus 2 root 2I. So we'll now get our second solution to that problem to be negative 2 plus 2 root 2I, and the third solution to be negative 2 minus 2 root 2I. So at this point, hope you enjoyed the video so far, and please, if you enjoyed the video so far, give a thumbs up. It's an encouragement to me. It doesn't cost you anything to just hit that thumbs up button and subscribe to gain access to my other videos, most interesting and advanced and more complex than this. If you are finding it difficult to ease your exams, your algebra tests or exams, make sure you stay up to date in this channel by subscribing to get all new uploads that will help you. Okay, go back to the video. Now you could see I'm trying to check the first solution, 3. The equation that was given was x raised to the power 3 plus x raised to the power 2 equal to 36. Now if you put 3 in place of x, 3 raised to the power 3 plus 3 raised to the power 2 is automatically equals to 36. That means right. Now it's an assignment. Check the remaining 2 complex solutions that we got later by yourself. Thank you so much. Please don't go without subscribing, without liking, and comment a question if you have. Thank you.